Okay, hi class. So right now we're going to be doing 1.3, which is introduces a new concept called rates of change. And so let's go ahead and get started. Now the rate of change of a function is you've probably seen it before with lines. So lines, their rate of change is always the same. So we call that the slope. The rate of change is just how much does a graph move up. So how far does it go up with respect to going to the right? And so we would call that the slope would be the change in y over the change in x. But for a line, it's a straight line, so it's always the same. In general, for a function, the rate of change, or the average rate of change, is the change in the output, so how far does it go up or down, divided by the change in the input, so right or left. And the formula for that might look kind of confusing. It's called delta. Delta is a math and physics term that means change. So this delta y means let's calculate the difference in the outputs, the change, how far did it go up or down, divided by how far did it go left or right. And make sure I'm recording. Okay? All right. And so the way we do that with function notation is pretty simple. It's just you take the output, the last output, minus the first input. So I'll write this in English. So you take the last output minus the first output. Because remember, these are y values. F of x is a y value. And you divide by the last input minus the first input. Now, you've actually seen this formula before. This is just rise over run. So you've seen it before as y2 minus y1 over x2 minus x1 for a slope of a line. So for a line, the slope is y2 minus y1. So this is the same formula, except for a line, the slope is just going to be a single constant number, because lines have like slope 3 or negative 2. For us, the average rate of change could be different on a function that's not a line, but it's the same formula. y2 is f of x2, y1 is f of x1, and x2 and x1 are the same in the formula. In general, it's just change in y divided by change in x. So let's go ahead and get practice on this. Let's take a look. Let me leave the formula up here. Let's take a look. So we want to find out the average rate of change of this function, -1 to 2. So I'm going from -1 to 2. And so it looks, the average rate of change means it's going to be how much did this function change on average. And the function went down. It went down from 4 over to 1 right there. So it looks like the average rate of change should be negative, and let's find out. Okay, so the formula is going to be delta y over delta x. So that's going to be f of the last, so it's the last output, so it's going to be f of 2 minus f of -1, all divided by the last input, which is 2, minus, now be careful, it's this x1 is a -1, so it's minus a minus. Okay, now we got to figure out what is f of 2. F of 2 was right here. Let me draw that in red. That point is 2, 1. So that means that f of 2 is 1 right there. So this is going to be 1 minus, and then find the graph again. This point right here, that was the first input and output, and that was the -1, 4. And so the first output is 4, so it's 1 minus 4. It's the y value. And then this on the bottom is 2, and then negative makes it +1. And so we just do the math. 1 minus 4 is negative 3. Divided by 2 plus 1 is 3. And so we get negative 1. And so this is the average rate of change. Okay. So what that tells me is that on average, on this interval, from negative 1 to 2, the graph moved down by 1. Because negative means it moved down. Okay? Okay, so moving this one says let's find the average speed. Now speed, okay, is the rate of change. You know, speed just tells you how fast you're going. It's how fast you're moving. And so if I'm given distance and time, I know that speed has to be, you know, distance over time. And so that's why when they ask for the average speed, what we're really asking for is what is the average rate of change, because distance over time is your speed. Okay, so this is the outputs. So these are outs, these are ins. Okay, and they went over the first 6 hours. So if they went over the first 6 hours, that means it's really like on the interval 0 to 6. So let me write that here. So the inputs are going to be 0 to 6. Okay? And since this is just a table, we can actually find the outputs. The outputs are going to be from, so here and here, because those go along with the 0 and the 6. And so our outputs are going to be from 10 to 282. Okay? With that information, we just apply the formula. So it's going to be delta y over delta x. It's the change in y, which would be 282 minus 10. Divided by the change in the inputs, 6 minus 0. Okay, remember inputs are x's and outputs are y. And then we just do the math, so that's 272 over 6, which I don't know what that is, so go to my calculator here, 272 divided by 6. And roughly equal to 45.33. So that was her average speed. Anna's average speed. Now remember, speed has a units, so it's just going to be the outputs and the inputs. So the output was miles, so it's going to be miles per hour, or mph. So she's going about 45 miles an hour, so pretty good speed. Okay, so let's move on. Example 3, compute the average rate of change of this function here. Okay, so we can do it with a graph, or we can do it just with a function. It's usually faster just to do it with the function, okay? But if you're interested in what it looks like, we can graph it too. So I'll do that real quick. But I'm not going to graph it every single time, just because it takes a long time. But you can definitely check it out. So that's our crazy graph right here. Now the thing is, we only wanted from 2 to 4. So I can change the window to be like 1 to 5. And so we're looking at this part of the graph from 2 to 4, which is here to here. And so we just want to take a look at that graph, find the average rate of change. It's going to be pretty big. So notice that, so the inputs again the x values go from 2 to 4. Okay. And the outputs we have to figure out. So let's go ahead and figure that out. So f of the last output, f of 4, is going to be 4 squared minus 1 over 4, which is 16 minus 1/4. Okay. Which is 15 3/4. So yeah, we'll just leave it like that for now. And then f of 2 will be 2 squared minus 1 over 2. Just plug it into that function. And this is going to be 4 minus 1/2. Okay, so now when we find the delta y over delta x, it's going to be delta y, which would be this, take away this. So it's going to be 16 minus 1/4 minus 4 minus 1/2. Notice I put the parentheses around this because we're taking away everything. Divided by the change in the inputs, which would be 4 take away 2. Okay. And that's going to give me 16 take away 4 is 12. Negative 1/4 minus a minus half. So it's going to be negative 1/4 plus half. So I have negative 1/4 plus 1/2. Which is negative 1/4 plus 2/4. And so that's 1/4. So I get plus 1/4. Okay. All over 2. And to do this, I'm not sure all the work, but just get a common denominator. This is 48 over 4, so I get 49 over 4 over 2. You can jump to the calculator now if you like. Or you know that this is 2 over 1, which means this becomes 1 over 2. And so we get 49 over 8. Okay. You could also just done that from here. If you just go to your calculator and you just go, okay, 12 plus 1/4 divide by 2. Okay, you get 6.125. And if you go with that, you say 2 fraction. You get the same answer, 49/8. Okay. All right, so that's the average rate of change. The graph is moving. Remember, positive means the graph is moving up, so it's moving kind of fast. I'm gonna let you try this one, and I'll post the answers on the filled-in notes on Canvas. Okay, so you can check your work after that. But we're gonna move on. We're gonna find this one. So let's go ahead and do that. Okay. So real quickly, so I'm going to move kind of faster on these ones, and if you're good with the concept, you can kind of skip ahead to the next one. But real quickly, if a is any number, we can just leave a there. So I know that the change in y or the change in x is going to be a squared plus 3a plus 1 minus plug in 0. You get 0 squared plus 3 times 0 plus 1 all over a minus 0. And we'll just do the math. We'll get the 1 will cancel out, and we'll be left with a squared plus 3a divided by a. And that's cool because the a comes out, and we get the average rate of change is just a plus 3. So it's kind of a nice way. We did this in general now, so we know for any interval for this function, its rate of change is always going to be a plus 3. Excuse me. Sorry, I have a little cough. Okay, so that's how we do that. This one don't worry so much about, but I'll post the answer to on the canvas for the filled-in notes. Okay, just know that whatever the inputs are, you just put that on the bottom. It's and on the top you just put the outputs. And always remember that it's last minus first divided by last minus first. Okay, this formula here is important, so make sure that you know it before going on. But remember, this is just the slope formula. So if you can remember y2 minus y1 over x2 minus x1, you can remember the average rate of change formula. Students usually do really well with this formula. Okay, we're going to be moving on to something different now. So when, let me see what time we have. Okay, we're doing good. So the only other thing we really want to talk about this section is just, so when a function increases and when a function decreases, all that means is that, okay, if we look at this function, it's really curvy, right? This is some type of cubic, sorry, some type of cubic function or fifth function or something like that. So it increases. What does that mean? That just means that, hey, put your finger on the graph, and if you draw on it, is your graph going up? And we always read left to right. So this graph is increasing right here, but then put it in red here. It's decreasing right here. Okay, and then it goes back to increasing right there. Let me make that green. Okay, so it just means that it's going up. So goes up, goes up. And right here in this little interval, it goes down. And we call that increase and decrease. So anyways, the way we write that is it's kind of confusing to have to write, like, draw the graph every time. So instead what we can do is we can say, okay, we're going to talk about the interval of the x values. So this graph is increasing. Let me erase some of this stuff. This graph is increasing from the left, and remember, negative infinity is over here, and positive infinity is over here. And so that means it's increasing from the left forever. So the way we write that is from the left forever means negative infinity. Okay? And then it goes up until it looks like it stops increasing right there. That's where it has that little flat spot, little hill. And that's -2. Okay? And where else is it increasing? Well, we said it happens here too, right? So 2, and it goes to forever to the right. So if it starts at 2, and then it goes forever to the right, the way we write forever to the right, we just use the infinity symbol. Okay? And the only thing to remember is that these are going to be open intervals. So we just always have to write it as parentheses, never brackets. So never brackets. Some people have trouble online when trying to put the answer in. If you think you're correct, just make sure that you didn't put a bracket. It's always going to be open. Okay? And it's decreasing. Well, it's going to be decreasing in the middle. And the middle is going to be in between these two, which was -2 to 2. So -2 to 2. Is that okay? So it goes from -2 to 2. That's when the graph is going down. And so we write that interval. Okay. So for instance, on this graph, you can see it's increasing here. And so we would say, just to get us practice, it's increasing on, looks like it goes forever, it had a little arrow there. Or we can say it starts at A. Oops, I wrote it as a hard bracket. A to B, looks like it's increasing. And it's decreasing from B to C, just to get you more practice. Okay? Remember, decreasing means go down, and increasing means it goes up. So some key terminology is maximum and minimum. Okay. And a maximum just means that, okay, you have a graph that hits this little crest, this little top of the hill. A minimum would mean the exact opposite. So a minimum, ooh, there's a typo here. This should say minimum. Sorry about that. Okay. And you can go back and read these notes a little bit. I don't need to read what's already there for you, but just understand that a maximum just is any part of the graph. Let me try to make it actually show up. Is any part of the graph where it has that top part. So like, for instance, on this Steph Curry shot, he shoots at this golden arc a little bit higher than most people, and he has this maximum right there, whereas most shooters have it right there. Okay? And it's true. I'm not making that up. Steph Curry did take calculus in college at Davidson, so pretty cool. Calc 1. Okay. Let's just, probably the easiest way to talk about it is just get a example. So this one, it looks like it has, we want to find your book calls it the extrema. It just means the maximum and minimum. Okay, this is the plural of maximum and minimum. This one only has one minimum. It looks like it has a minimum right here, and we call that a local minimum. The reason it's local is that the graph does get lower than that, but in this little area it went from going down to up. So anytime the graph changes direction, we'll call that a minimum or a maximum. And this one is the minimum, and we call that a local minimum. And can you see where there's a local max? The local max, again, is going to be wherever the graph changes direction. And it looks like the graph changes direction right here. It goes from up to down. And so that right there would be a local maximum. Okay? Now, we're pointing at a graph, but the way we express that is that we say, okay, the local max, let's do the local min first. The local min occurs at, we just do the xy pair. So the x value is -1, and the y value, it looks like it's -2. Oops. Okay. And same thing for the local max. The local max is going to be at 1, 2. Okay? And the book does this, and math people do this too. We talk about the local min, this is where it occurs, so this is the coordinate that it occurs. But if we just want the local min value or output, just give the actual output. And this, it's like thinking if this graph was talking about profit of your company, you would want to know what is the minimum actual profit. I don't really care so much about where the x value is, just tell me what is the money. And so that's the output. And so we would say just y equal, you just say -2. And for the local max value or output, we would call that 2. Okay? We want both sometimes. So sometimes, I'll ask, or the online will ask, what's the actual coordinate there. Sometimes they'll ask what is just the actual output. It's pretty easy to tell, because if they want the value, they'll say, what is the local max? What is the local max? If they ask where it happens, then they'll ask for the coordinate. If you have any questions on anything, you turn it to me. Just ask, see what I'm asking for. Okay. All right. How are we doing on time? Okay. I'm trying to get a little bit shorter because I think the last videos are a little bit too long. So you guys let me know. Give me feedback this week, okay? So now that's when the graph was given to us. So I drew the graph for you. let's go ahead and graph a function, and we'll learn how to find the max from the minimum. And you can always do it on a calculator. It's really nice. So let me show you how. You do 2 over x plus x divided by 3. Okay, that's my graph. And then I'm going to make sure it's in normal zoom, so I'm going to hit zoom standard. And okay, so it looks like, and I don't think I can draw on the screen here, but it looks like their minimum is right, the local min is right there. I don't know if you can see that, but let me just sketch the graph over here. So it looks like it goes like this. Something like that. And so it looks like there's going to be, where the graph changes direction is right here and right here. It goes from increase to decrease, and it goes from decrease to increase. Going up, then down, and then on this side, it looks like it's going from down to up. So it looks like these will be the local mins and maxes. Okay, this right here will be a local max, and this right here will be a local min. Okay, now how do we find that? It's really easy. If you go over here to your calculator and you hit the calculate button, so hit the second calculate. So let me show that again. I hit second calculate. I'm in the calculate menu, and number 3 and number 4 actually are the minimum and maximum buttons. So if I want to find the minimum, just hit 3, hit enter, and it's going to ask, okay, where do you want to look? So let's look on the right side. So it just is asking for a bound. So let's say, okay, I think it's right around here. Let me say that's, oops, the right bound. So that was wrong. Let me do it again. I messed up. Let's go minimum. So it's going to ask for the left bound. I think it's around there, but I think it's definitely around here. So I'll go to the right. And then ask for a guess. You can always hit enter, but you can get close to. I think it's around here. Okay. And then voila, it tells you the minimum. It looks like it's around 2.45. And so it looks like it's right around 2.45, comma 1.63. Okay. And you can do the same thing for the maximum. So I'll do it again. I'll go second, calculate. I'm going to find the maximum. And I want to go over here. So left bound, just make sure you go to the left of where you think the max is, okay? And the right bound. Okay, I think I've gone past it now. And get close to it. And these arrows right here kind of help you. And looks like the max is right here. So it looks like that is going to be, I don't know where to fit it. Negative 2.5, 45, sorry, comma, negative 1.63. Okay, sorry, it's kind of messy, but that's how we find the local min and the local max. Okay, and so if I know the mins and maxes, local mins and maxes, I can answer this part, the increase, decrease, because increase, where's that going to happen? Well, the graph is increasing before that. So if it's increasing before that, that means, remember, negative infinity is over here, and positive infinity is over here. So the graph is increasing from the left forever, so it's going to be negative infinity. And it goes until that point, till negative 2.45. And remember, we write these as, these are x values, okay? So the x went from negative infinity, and the graph's going up, 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 until right here, which is negative 2.45. Okay? Now it looks like the graph's increasing over here too on the right side. because it goes down, 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 and then it has this low spot. From the minimum, it looks like it goes back up again. It increases. And so I'm going to have another interval, and that's going to be from the minimum, 2.45. Remember, it's the x values here. And then it's going to go up to, it goes to the right forever. So if it goes to the right forever, we just call that infinity. Okay? And decrease, same thing. It decreases from negative 2.45. And then it goes down forever. Draw a different color here. It goes down, 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 down. And so it's from negative 2.45. It looks like until 0. Okay, because it has this kind of, we call this an asymptote, and we'll talk about that this semester. But it looks like it goes down. And then it also looks like it decreases from 0 over to there. So 0 to 2.45. Excuse me. Okay. So again, I'll write the answer to this and post it on Canvas for this one, so you can help you out with that one. Okay. And I'm gonna go ahead and finish up just to get more practice with increase and decrease. Okay. Let's go ahead and get some practice. So a constant function, it never increases and it never decreases. So none. So, and the reason for that is that the graph is not going up or down at all. So it has no increase, no decrease. This function y equals x, this thing is increasing all the time. If you put your finger on the graph of a diagonal line, this positive slope one, it's always going up because the slope is positive 1. So this is increasing all the time. And so we just say increasing negative infinity to infinity. Okay? The quadratic function, that guy is going to be increasing on the right side. So increasing from 0 to infinity. And it's going to be decreasing from negative infinity to 0. Okay? And I'll just quickly fill this out. This cube root guy, this guy is increasing all the time. And I'm just telling by looking at the graph. You know, it's pretty straightforward. If you just look at the graph, just put your finger on the graph. Is it going up or down? This guy's always going up, so it's increasing forever. The square root function is always increasing as well, but it starts at 0. So we'll say from 0 to infinity. This absolute value, it increases exactly the same thing as the quadratic function over here. So it's going to be 0 to infinity. And it's going to be decreasing from negative infinity to 0. Again, it's going up here, but it's going down here. Okay, and that'll be it for now. We can do one more. So this guy increases. Hopefully you can see. It might be confusing because the arrow is going down, but we always read increasing. Is it going up or down as we go from left to right? Just like we read in English from left to right. We read these off left to right. So as you go left and you put your finger on the graph, is the graph going up or down? And so as I'm going to the right, the graph goes up. So it's always increasing. And so this guy is increasing on negative infinity to infinity. All real numbers. Okay. That'll be it. These ones aren't so important, but you can definitely try. This guy's decreasing here, and it's also decreasing here. And this guy is increasing here, but decreasing here. Okay, that'll be it. So I'm going to post, I'll post the answers